This is the review for Unit 1, Chapter 2, Chemical Bonds and Compounds for Physical Science in 8th grade. All right, the first thing to know is, number one, what a compound is. A compound is a substance that is made up of two or more different types of atoms that are bonded together. Now, this is typically done in a chemical bond. The way to think of a chemical bond is like those pictures you've seen of skydivers where they're grabbing hands and they're holding on together because there's a group of them going together. And that's what happens in a chemical bond is these atoms are held together like they're holding hands. Now, the properties of compounds will depend on how those atoms are arranged together. We'll talk about that a little bit later. But don't forget that the properties of the compounds are often very different from the properties of the elements themselves. Compounds always contain the same number of atoms of an element in a specific ratio. For example, like with water, you're always going to have H2O. You're never going to have a different number of either of those, because if you did, you'd have a different type of compound. Ratios are written a specific way. In this case, for H2O or water, we would actually have a 2:1 ratio because there are 2 hydrogen atoms to 1 oxygen atom. Next thing is to remember how to write a chemical formula. Now, chemical formulas, those are the representation, just like I just had. Again, let's use H2O. This is a chemical formula, this being hydrogen, this being oxygen, this being the number of each of those types of atoms. In this case, this is the chemical formula. Let's try a different one. Let's try methane. So methane has a carbon atom with hydrogen atoms, but in this case there are 4 of the hydrogen atoms, and this would actually be written as a ratio, just to go back, of 1:4. Make sure that you realize that as you're looking at these different chemical formulas, that these are different compounds. Even though some may have the same types of atoms, such as, in this case, NO or NO2, or even N2O. These are all different chemical compounds with different properties, and you should be able to figure out which one's which by seeing how they interact with other compounds or other elements. Now let's talk about chemical bonds. Now those bonds are the glue that holds things together. So remember, we've got chemical bonds. We talked about that earlier. And so they equal the glue that hold things together, or like I talked about with those hands. These bonds occur when the electrons in the electron cloud around 2 atoms interact. So if I've got 1 atom, I've got 2 atoms, and they've got their electrons out here, they're going to interact with each other, and that is going to create the chemical bond. Remember what ions are. Ions are atoms that gain or lose electrons. So remember ions, and they either gain or lose electrons, right? Gaining electrons change it to a negative ion. If we gain, if we lose, it's going to change it to a positive ion because we're going to have more protons. This one will have less protons than electrons. The next part's pretty important. Remember how the grouping of elements on the periodic table, how that plays in how a compound is created, and how those chemical bonds are created between different ions. Remember, if we have a group over here, let's say group 1, and we have a group over here, remember we're going to leave group 18 here alone because they don't like anyone. So group 17. So these guys are going to interact with each other, right? And group 2 and group 16, they're going to interact because they have a either surplus or not enough of the electrons in order to create that bond. So group 1 metals, so they're going to lose 1 electron to form an ion with a single positive charge, and group 2 metals commonly lose 2 electrons to form ions with 2 positive charges. So other metals are going to form positive ions, but the number of electrons they may lose varies. Now nonmetals form ions by gaining electrons. So group 17 nonmetals are going to gain 1 electron to form ions with a -1 or 1 negative charge. The nonmetals in group 16 gain 2 electrons to form ions with a -2 charge. So these guys are going to have a -1. These guys are going to have a -2. These guys are going to have a +1. These guys are going to have a +2, and so on. Now, ionic bonds. Ionic bonds. Remember that number 1, that first part of that word is ion. So these are going to be ionic bonds that are created between different ions of different elements. So ionic bond is the force of attraction between positive and negative ions. And so you're going to have a ion with a positive charge is going to be attracted to an ion with a negative charge, and they're going to create that bond between them. That force that bonds them together, that electrical force, it occurs in all different directions. So when they're attracted to each other, they're actually attracted to all nearby ions with that opposite charge. So this creates a bond between them all, which is going to create a network of those ions, this is when you're going to get that compound. Now, ionic compounds are very stable. Their crystals are very strong. The shape of them will depend in part on the ratio of positive and negative and the size of those ions. Now, those bonds, again, that crystal is going to be, though it's going to be very strong, it's going to be so strong that when it splits, it's going to break and shatter. It is not going to bend and be malleable. It's going to actually shatter apart. Naming an ionic bond, remember that the positive ion is placed first. So the positive is first. And remember that the second one is going to get either that "-ine" or "-ide" ending. Another thing I want you to remember about ionic bonds are they do not conduct electricity all that well. However, when they are dissolved in water, so when ionic compounds are dissolved in water, they actually separate into positive and negative ions. So you get the positives over here and the negatives over here. And because they're separated, they're able to move freely. So they can go wherever they want. And they make solutions that are good conductors of electricity. So yes, when they are dissolved in water, they are good conductors. The next one to remember is a covalent bond. So let's put up a covalent bond. And a covalent bond, remember, is when they share electrons between the different atoms as they connect and create that compound. In this, neither atom gains or loses, so there is no gain or loss, right? And so there are no ions. The number of covalent bonds that an atom can form, this is going to depend on the number of electrons that they have available. So atoms in the halogen group and the hydrogen can contribute only 1 electron, right? Because they have that, remember, that +1. And these guys over here have that -1. And these are the 17 group, and these are that first group. So the second group is going to have a +2. These guys over here in 16 are going to have a -2. So remember, so that is going to control how many bonds that they can actually create. So these guys are going to create a bond with just 1 other atom. These guys are going to create a bond with 2 other atoms. Or they could even possibly create a bond with one of these guys, and they will just share those atoms between the 2 of them. Remember what a molecule is? And that is a 2 or more atoms held together by the chemical bond. So it's chemically bonded. And this can contain anywhere from 2 to thousands of atoms. And when you're talking about covalent bonds, don't forget that polar covalent bonds. So polar covalent bonds. So these are still covalent bonds where they are sharing the electrons, but they're shared unequally, so they're not equal. And so one, or the electron is attracted to one nucleus of an atom rather than to both of them equally. Covalent bonds, like we talked about earlier when it comes to ionic bonds about them being conductors of electricity, covalent bonds are the exact opposite. So these atoms are organized as individual molecules. So it means that they melt and boil at lower temperatures than ionics, but it also means that molecules stay together when dissolved in waters. And so covalent bonds do not conduct electricity well, or at all. Last part of this section is the molecular structure. And don't forget that molecular structure influences how substances feel, how they touch, how they interact with everything else. And that every molecule of those elements that create those are in those covalent bonds, that they all have a specific three-dimensional shape. Again, so if I have an oxygen, it is always going to fit with 2 hydrogens in order to form water, and in this case it is always going to be in this shape. You'll never see an oxygen with hydrogens in this way. It doesn't happen that way. It's always in this 90-degree shape. And now on to lesson 3. This is about chemical bonds again, but this time we're going to talk first about metallic bonds. So remember how metallic bonds are created, that these are created through the chemical bonding of metal atoms. They're going to share electrons equally in all directions, so equal sharing. Okay. And that means that the electrons are easily able to move amongst the atoms of the element, and this creates that metallic bond. Metal elements or compounds are good conductors of electric current, good conductors of heat. They have high melting points, and except for mercury, they are solids at room temperatures. One really specific thing that I want you to remember is that they're easily shaped by pounding and can be drawn into wire. And the reason I want you to remember this is that all the in metal compounds, atoms can slide past one another. They're not stuck in a specific spot. They can move about, which is why when you pound on it, it allows the metal to be moved and shaped because those atoms can just move around. I remember the analogy that it's kind of like the atoms are swimming in a pool of all the electrons because they're all shared together, they're all grouped around them, so those atoms are able to move around. And the last item is to remember that elements can actually look different depending upon how those bonds occur. So covalent bonds do not always form small individual molecules. The properties of each can depend on how the atoms are bonded to each other. All right, hopefully this should give you all the information you need. Make sure, just a couple of last quick notes, make sure that you understand what a ratio is, make sure you understand ionic and covalent bonds, understand what is going on in the electrons in all of those, how to tell the difference between different elements or compounds, know how to read the periodic table and be able to figure out how the ionic bonds would form based on the positives and negatives and what grouping they belong in. And that should do you. So good luck. Bye.